Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting presentation for diagnostic trouble code P0406, which indicates a high voltage in the EGR valve position sensor circuit. The EGR, or exhaust gas recirculation system, plays a critical role in reducing nitrogen oxide emissions by recirculating a portion of the exhaust back into the engine's intake manifold. The EGR valve position sensor is essential in monitoring the position of the EGR valve. In the Honda Accord models from 2012 to 2017, the EGR system is fitted with a 5P connector that integrates with the Powertrain Control Module, PCM. The PCM uses the voltage readings from the EGR valve position sensor to regulate the engine's performance and emissions. If there is a high voltage signal detected, it can signify potential issues in the EGR system, leading to performance problems or increased emissions. We aim to systematically identify and resolve the issues related to this DTC using the outlined diagnostic protocol. In conclusion, DTC P0406 reflects issues within the EGR valve position sensor circuit, primarily indicated by high voltage readings. This condition can lead to numerous performance issues, including engine roughness and increased emissions. A systematic diagnostic approach is critical for accurately identifying the problem areas associated with the EGR system. Completing each troubleshooting step carefully ensures that potential wiring issues or component failures are addressed effectively. Timely repairs based on diagnostic findings can prevent further complications, allowing the vehicle to run optimally. Overall, understanding DTC P0406 not only aids in immediate fixes, but also enhances the longevity of your Honda Accord by preventing future engine performance issues. The error associated with DTC P0406 specifically pertains to the EGR valve position sensor circuit, indicating a high voltage reading. The EGR valve position sensor is responsible for relaying the position of the EGR valve to the PCM to optimize engine performance and emissions. It is strategically located near the intake manifold for efficient monitoring of the exhaust gas flow. If the sensor detects a voltage exceeding 4.88 volts, a signal is sent to the PCM, setting off this DTC. This high voltage could affect the vehicle's operation, leading to problems such as poor engine performance, increased emissions, and, in severe cases, triggering the check engine light. Therefore, understanding the role of the EGR system and the implications of this DTC is crucial for further diagnostics and repairs. Several possible causes can trigger DTC P0406. Firstly, a defective EGR valve can cause high voltage signals by failing to function correctly, which might involve internal faults or debris affecting operation. Secondly, poor connections or loose terminals at both the EGR valve and the PCM can result in unreliable voltage readings, potentially causing intermittent failures. Lastly, a faulty PCM may misinterpret data, affecting engine performance and becoming a source of erroneous DTCs. All these factors highlight the necessity of thorough inspection and testing of each component involved in the EGR system to establish the root cause effectively. When DTC P0406 is triggered, various symptoms may present themselves, indicating the vehicle is experiencing issues related to the EGR system. The most common warning is the illumination of the check engine light on the dashboard, alerting the driver to a malfunction. Additionally, drivers may notice a rough engine idle, reflecting that the engine is not performing optimally due to improper exhaust recirculation. Another significant symptom is an increase in emissions. As a result of malfunctioning EGR systems, the efficiency of emissions reductions can be compromised. Recognizing these symptoms can prompt timely troubleshooting to mitigate further performance degradation and emissions compliance issues. The first step in troubleshooting DTC P0406 is to verify the problem accurately. Begin by pressing the engine's Start-Stop button to select the on mode. Using the Honda Diagnostic System, HDS, check the parameters of the EGR valve position sensor to determine if it exceeds the voltage threshold of 4.88 volts. If the current conditions do match the threshold and signal an acceptable voltage, it indicates that the failure is indeed duplicated, and you can proceed to the next step. Conversely, if the readings do not match, this may suggest an intermittent failure, where the system appears normal. In such cases, inspect for poor connections or loose terminals at both the EGR valve and the PCM. By confirming the situation with accurate data, it sets the foundation for follow-up diagnostic steps. The second step focuses on determining the possible failure area related to the EGR valve position sensor. Start by pressing the engine Start-Stop button to select the off mode and disconnect the EGR 5P connector. After disconnecting, switch the ignition to the on mode. It is crucial now to measure the voltage between the defined test points of the EGR valve 5P connector while it remains disconnected. You will be checking test point 1 at connector number 2 for voltage, indicated in pink, and test point 2 at connector number 3 for voltage, indicated in blue. You should find about 5 volts at these points. If this voltage level is observed, it typically indicates that the EGR valve is faulty and requires replacement. If the voltage is not present, it indicates further issues needing additional investigation in subsequent steps. In the third step, attention shifts to checking for an open wire in the SG1 line. Begin by toggling the engine's Start-Stop button to select the off mode. Use the HDS to jump the SCS line, effectively initiating the troubleshooting short circuit. After this, disconnect the relevant PCM connector C51P. Check for continuity between the designated test points using the specified test conditions while ensuring both the EGR 5P connector and PCM connector are disconnected. Test point 1 will be the SG1 line, blue, at the EGR valve 5P connector, and test point 2 will correspond to the blue wire at the PCM connector, C51P, number 33. If continuity is confirmed, it reflects that the SG1 wire is functioning correctly, which might require an update to the PCM if the software is outdated. Alternatively, if continuity is absent, it indicates that there is an open circuit or wiring issue present between the PCM and the EGR valve, requiring repair. After completing the necessary repairs based on prior troubleshooting, it is critical to perform final repair verification to confirm the resolution of DTC P0406. Start by pressing the engine Start-Stop button to select the off mode and ensure all previously disconnected connectors are securely reconnected. Next, exit the SCS mode utilizing the HDS to ensure the diagnostic system is correctly configured to continue testing. Turn the ignition back to the on mode and reset the PCM through HDS, which allows it to refresh its stored data and adopt any new configurations. Subsequently, execute the idle learn procedure to assist the PCM in adapting to engine operations accurately. Finally, check for any pending or confirmed DTCs with the HDS to confirm that DTC P0406 is no longer present, indicating successful repair. Preventive maintenance is essential to mitigating DTC P0406 and similar issues in the future. Regularly inspecting and cleaning connectors involved with the EGR system can help avoid electrical faults caused by corrosion or dirt buildup. Furthermore, ensuring that all connections are secure can prevent intermittent signals that could lead to erroneous DTCs. Additionally, keeping the PCM software up to date is vital for optimal processor function and communication between components. Regular software updates can help in identifying and correcting any glitches affecting functionality. By integrating these preventive measures into routine vehicle maintenance, the longevity and performance of the EGR system can be significantly enhanced. Please like and subscribe to the channel. See you next time!